go through this quickly. So it says, which of the following is the weakest acid? So the options are just going to be a bunch of Ka's. So choose the one with the smallest Ka value. And look, if it's 8.5 times 10 to the negative fifth, or 1.2 times 10 to the negative fourth, this is what we're looking for, not that. Okay? It's the largest negative exponent is the smallest number, if that makes sense. So that's what we're looking for on number 1. Okay, next. This one, the multiple choice I have, it's combined with chapter 15 and 16. And the program I use to do these doesn't even work on our computers anymore. So you're getting this version. So you already have this question. You simply take this over those and plug in these values. And it's going to be a number that you've seen before on your calculator. All right? It's how old I turned in 21 years. No, 19 years. That's something like that sometimes. All right. Next. Of the following acid, blank is not a strong acid. This is where everyone freaked out and said, how dare you? All right. Well, you were supposed to memorize these decades ago. You can start memorizing them again. We put that list up yesterday. HCl, HBr, HI, HClO3, HClO4, H2SO4, and HNO3. I think that's all. If I skipped one, I skipped one. But the list was up there yesterday. The magnitude of Kw. Does anyone remember what Kw even is? It's water. Do you remember the value? Does this seem like a big number or a small number? It's really small. Remember that, and you can get your answer. It's a really small number. Of the following equilibria, only blank will shift to the left in response to a decrease in volume. Decrease in volume really means an increase in pressure, right? So if it's an increase in pressure and it wants you, so let's just say A and B, all right? If it's an increase in pressure and it's shifting left, then A must have less moles, and this must have more moles. So we'd say it's like 1A goes to 2B. That would cause a shift towards the smaller number of moles. Does that make sense? So you add the coefficients, and then only one of the options will have a smaller number on the left than the right. Fair enough? What is the pH? If H plus is that, you can do that right now if you want for that answer. How would you do that? No, not inverse log this time. Negative log. All right. So this should just be like a free 2-point free response question. You take the negative log of that value, I don't know, something 3 point something maybe, 2.9, 3.16, 2.6. Okay. Not bad, right? That's just plug and chug. What's the concentration if the pH is this? So that's not hard either. That's just now the inverse, right? 10 raised to the negative 4.282, and that will give you that answer. So those are just straight calculations. You okay with this so far? At equilibrium, blank, and then it's like a bunch of sentences. It's just pretty much, yeah, it was from the other test. It's just the definition of what equilibrium is. Okay? Would you like me to hand back your last test? Okay. Make me do that when I finish this. They're just going to pile up on each other. All right. This one is also off of the last test. KEQ for the forward is that. What is it for the reverse? All right. It's 1 over that. Okay? Not negative 794, though. The conjugate base of H2SO4, HSO4 minus is, so remember that? That's definitely from chapter 16. The conjugate base is the anion of the acid. So it's treating this as an acid, right? So that means it would give away that H, so there's your conjugate base. Only one part's missing. It would be -2 once the H is gone. Fair enough? Conjugate base is the anion of the acid. So take the H off, and whatever's left, that's your conjugate base. The equilibrium for this is that at equilibrium. So this is just asking, like it's sentences again, but it's pretty much asking, is there more product or reaction? Okay. This negative sign right there on that exponent is enough data for you to answer this. If it's a negative, is it a small number? Yeah. If it's a small number, then it must be what dominant? Tell your partner. 3x. Okay. Now, here's Le Chatelier's principle. Okay. Consider this. It predicts the moles of H2 will increase with. So we want to make this go up. Think about that for a second, because there's lots of ways to make that go up. Think of at least one and tell your lab partner. Whether it's endo or exothermic, so heat won't help, right? They are all gases, so you could say, so here's a 2, here's a 4, right? You could say a decrease in pressure, because a decrease would cause it to go towards the side with 4 instead of 2, right? You could say an increase in NH3, or you could say a decrease in N2. Those are your 3 options. Is that fair? Good? Opposed? Good? Okay. The POH, if it has hydronium ions. That's a good question. Why don't you try that on your own for a minute? Negative log of that, and then I would like say 14 minus that. And that would tell me my answer. Okay with that? Because pH and POH together, whoops, I should put the minus right here too. They equal 14, so you can take 14 minus the pH to get the pOH. I like that question. Consider this, the equilibrium cannot be established when blank is placed. Huh. Interesting. I wonder what I'm even asking there. I'll have to check that one out. What's that? Yeah, when a rock. When a taco. The answer finally is a taco. Wow. Point that out to Parker if you haven't. Okay, make me come back to that one. It sounds like it could be a trick question. According to the Arrhenius concept, an acid is a substance that... All right, Arrhenius was like the very first thing, wasn't it? H plus has to go up. That's what you're looking for in a solution. Not really. Okay, we all right with that? Yeah. The definition of that is it makes hydronium go up. Okay, so we did a question just like this earlier. We can make CO2 go up by doing a few things. This tells you it's exothermic, so I'm going to write the word heat here. So the only difference in this question and the one before is now there's heat. So we can make CO2 go up by cooling the system, because if we cool it, we go towards heat. We could make it go up by decreasing the pressure, because there's 3 moles here and 2 moles here. We can make this go up by increasing CO2. We could make it go up by decreasing O2. Those are all of your options. Yeah, Le Chatelier's principle is gold for a test question writer because there's a million ways to answer. All right, nitric acid is a strong acid. This means that. So this question is just a definition of what a strong acid. The word completely is probably in there. Completely dissociates when placed in solution. No. For the endothermic reaction, so that means heat's over here. This one was on your test before. So this is the same exact question again. Le Chatelier's principle is always on the AP test. So if you wonder why I'm testing it, you'll probably get some even in chapter 17. It's because it's not that bad, but it is very often tested. So once again, just a lot of things here can make this, let's see, will increase. So to make this go up, we could decrease that. We could increase this time. Well, okay, hold on. Let's talk heat first. If we want this to go up, we would heat the system because then it would go away from the heat term. And then this one, it's not tricky, but this is the only gas, right? So to make this go up, we want to decrease the overall pressure. Okay? Because it's a 1 here and a 0 here. If we decrease the pressure, we're more likely to go towards the 1, and that would cause that side to increase. The value of the equilibrium constant, this was missed way more than it needed to be, probably by over half the students here. There was C and D that were very tempting. Changing the initial concentration of this, changing the initial concentration of that. Nope, nope, and A, the temp. I can't guarantee that it's A, again, because when you make these tests and I would import them, the options were always different. But if you remember, or if you just look, every single one of these that gave you what Ka was, it gave you the temperature it was happening at. And that is because K is different for every single temperature that there is. Okay. This is the last question. Which of the following expressions is the correct equilibrium, whatever, you know that word, constant expression for the equilibrium between dinitrogen tetroxide and nitrogen dioxide? So it's just saying Ka equals something over something, and then it will have it the wrong way, and then I'm sure it will have it where it doesn't have the 2 also. This would be the correct one. Okay? Check for it to be in the right order of products over reactants, and check for it to be squared. Yeah, come farther back here also, like way back here. We'll talk about all this crap that we're going through. We already did most of it, so don't panic. Oh, where are you? Oh, geez. Whoa. Jeez Louise. Some anger going on. You're full of electrons. All right, so we did this one, Hober. We already did it in the notes. It's on the test. We already did hydrofluoric acid. It's also on the test. And we also did ethyl amylene. And remember, this one was the tricky one because it was the base. Okay? Remember that. The base meant we did all of the math exactly the same, except for the end, when we got the pH, it was really the POH. So the answer was really 14 minus our answer, like, let's say 7.2 or something like that. Does that sound familiar? I recorded it. We did it yesterday. I will upload those. Down here, there definitely is there's a D. There might even be an E. I'll have to look at it. But, okay, that one question we got to go back and look at, right? I heard it. All right, percent ionization. It looks a lot like what we just did, where we take the concentration of H plus and divide it by the initial. But this time we don't square it or anything. We just divide it by that and times it by 100. You times it by 100 because that's how you find percentages. Okay? In this example, the H3O is 4.2 times 10 to the negative third. All right? So 4.2 times 10 to the negative third. The initial was 0.1. You divide that and multiply it by 100. I think it's just 4.2%, isn't it? Okay. Okay, now, why it's rarely tested is because it's, I guess, third grade, sort of. Like, it's chemistry, but it's like, what? Okay. Typically, it doesn't just give you this, though. How have we been finding this week? From the pH or the grams. Good. Both the person in front of me and behind me got both. Nice. So it would say, all right, your pH of a, I don't know, no, that's too big, 0.025 molar solution is, and who cares what it is, like the identity. Yeah, it is. I meant like of HCl or whatever. Is 3.5. What is percent ionization? Okay, so we need the H plus concentration over the initial times 100. So we can use this to find the H plus. This is the initial, and we just plug and chug. So negative log 0.025 is 3.16 times 10 to the negative 4. We then take that and just divide it by 0.025. Sorry, I did that moronically. The math, this is the right answer still, I just didn't write it. Sorry, we take 10 to the negative 3.5, and that is what you put here. I'm sorry. And divide that, and you get 0.0126. Did you already multiply that by 100? Okay. Times 100, so you get 1.26. Okay? So one of the most important things for this chapter is to remember what you can find from pH, because we use that a lot. That's our H plus concentration, which is also our X. We will use that a ton. Okay. You okay with that? Okay, we're going to go through a lot of slides here, because we already did this stuff. pH from Ka, we already did that, like a lot. That's what those things were. Okay, polyprotic acid. The only thing you need to know here, a polyprotic acid, poly means more than one, protic is your H plus, and it's an acid. So like carbonic, you're used to that one, H2CO3. It can go to HCO3 minus and CO3 minus 2. What you need to know is that they have more than one acidic proton, so they typically have more than one K value. Now, this is never on a free response, because that math is really hard. But it is often in a free, or in a multiple choice, and it will ask you which is the more important one. Almost all of them, and all of them on this list, the first K is what we care about the most. But if it says which K is more significant, we just need to look at the one that is the larger value. Yeah, we don't measure that one because it's strong. So it's like dividing by 0 again. All right. But then the second one is not as strong. Still, it's to the negative 2, so even that one's actually pretty good. Yeah. It's so, anyway, all you need to know here, polyprotic acids have multiple K values. And the one we care the most about is the largest K value. Oh, a nice toasty 28 degrees out there. You guys know why it snowed last night, right? No, because there's a track meet today. It happens every year. It can even happen in May, so I apologize in advance. All right. Now, yeah, soccer will still practice. We'll practice too. Yeah. All right. We already talked about weak bases. We did a little bit of math on weak bases. We also did this exact same conjugate base and acid stuff. So when I go through this, don't think, oh, we didn't learn this stuff. Okay, there's a few practice problems. We'll come back if we have time. KB can be used to find OH and through it pH. That's what we did yesterday. Do you want another practice one of those? I bet I have one coming up. What is the pH of a 0.15 solution of NH3 where you end up with this and it tells you your KB is 1.8 raised to 10 to the negative fifth? You want to take a minute and do that. It gives you the equation right here to each other. So it's x squared over my initial concentration is 0.15 equals my KB, 1.8 times 10 to the negative fifth. So I multiply both sides by 0.15, and that makes that disappear. Then I take the square root of this. When I do all that, I get my x value. And remember, x isn't the answer, but it's going to help find the answer. So what do we end up with for x? 0.00164. Okay, now I'm going to take the negative log of that, and that's going to give me some number, 2.8. What's that? 2.78. Now, some of you would circle that and move on, but remember, since this is B, this is really the POH, so I need to take 14 and subtract 2.78 and get 11.22. And that would be my pH. A good thing to remember so you don't screw these up, because you can do all this math and be like, oh, hey, there's my answer. But remember, if it's a base, the pH has to be above 7. So you'd be like, oh yeah, this has to be bigger than 7. This isn't. Oh, that's because that was POH. I almost forgot. Good thing Davidson told me to remember a base should be above 7. Subtract it, and then be ready to roll. Are we comfortable with bases? It's all the same, except for subtract from 14. This is all the same stuff. Okay. This will sort of lead us into chapter 17. Log of the negative pH. So we take 10 raised to the negative 10.11. Okay, that's that. That's how we found x. You with me on that? I'm kind of combining everything. I divide by the initial, which it told me was 0.018. Okay. Yeah, it should be a really small number. 3.35 times 10 to the negative 19. Okay. All right, that's a really, really, really small number, but that's fine. We'll live. I think. Now, my H plus concentration was this, right? H plus was whatever that answer was, not the squared. You with me? Because remember, x is what H plus is. We would have squared it. So does anyone still have that number in their calculator? Okay. And that's fine because this is a really small number, but that's for H plus, and we're talking about a base. So that's fine. Now, what's that? Yeah, this is your H plus concentration. And then I'm going to apply this. So I have Ka, so I want Kb. So I'm just going to take this and divide it by 3.35 times 10 to the negative 19. And that will tell me Kb. And this is where the wheels will fall off the bus a little bit. Yeah, what'd you get? Okay. So the math is fine. The way I wrote my problem out, these numbers wouldn't work, but the math is fine. Why is it so big? You got this as a small number? It should be it should be to the 5th power. If you got to the negative 34, this whole thing has to be in parentheses in the denominator right here. Because what it does, if you don't parenthesize it, it does that math and then raises that answer to the negative 19, which is not what we want to do. So as written, this problem was kind of a disaster, but our math is just fine. Okay? That's what happens when you make up chemistry numbers. Okay. I don't know. Bell rings in 2 minutes, so we'll call.